Hello everyone and welcome to another video. Today I am going to talk about the second aquaponics system that me and my coordinator built as part of my Master Thesis project. As you can see, this is a more complex system than the previous one. It combines the nutrient fill technique with a deep water culture system. This was a system with a fish tank of 176 liters and a separate biofiltration and mechanical filtration unit of 60 liters. The deep water culture unit in itself had 98 liters. In the fish tank, we had 7 goldfish. In the nutrient film technique system, we planted mostly strawberries and tomatoes, whereas in the deep water culture system, we planted mostly lettuce. But before I move on into the construction, here's me from the past actually giving you a little bit of a tour. Alright, so my name is Enrique, I come from Portugal and I study environment engineering. This is an aquaponics system that me and Luis have built. An aquaponics system is a way to grow fish and plants together. So here is a fish tank with some goldfish. Maybe we can even see them.
Maybe.
Yeah, over there in the bottom.
I don't know if somebody will see it, but I can see it.
Yeah, they're a bit shy as well.
Okay.
And the fish, they do their thing, they eat food and they poop and pee like other living things. And the water that has this waste is pumped to this filter, 2 of these. And in the filters, there is naturally occurring bacteria which convert the fish waste into plant fertilizer. And then that plant fertilizer goes to the plants, and the plants clean the water. So it goes through this pipe all the way around. It feeds strawberries and tomatoes and into this floating raft, and you can see the roots growing. So they're growing without any soil, just floating. And finally the clean water goes back to the fish tank. So from a little hole here that goes straight up to
the fish.
Yeah. Okay. So the fish make the food for the plants, and the plants clean the water for the fish.
Good.
So starting with the construction, this is the pump that we used. We began by positioning the fish tank in the floor, making sure it was somewhat leveled, and then deciding where we were going to place the deep water culture tank and the nutrient film technique pipes. So this is an early position, you could say, while we were still deciding. Eventually, we decided to use this metal frame as a support for the filter, resting right on top of the fish tank. The filter, which, as you may have seen in the previous picture, contained light expanded clay aggregate and charcoal as part of a joint effort to provide enough surface area for the nitrifying bacteria to develop and also to help trap some of the solids. Eventually, the system would look closer and closer to this. So as you can see here, we have placed the pipes more or less in position. These are still temporary positions at the time while we were deciding the height and if we would be able to get the flow going just by gravity from the filter. We also started drilling the holes in the styrofoam that would rest on the deep water culture where we would put the lettuce plants. Here you can see the drilling of the nutrient film technique pipes where we would place the tomatoes and the strawberry plants. Here you can see the net pots already in position, and here we actually properly secured the pipes in their position, so the system is pretty much ready to go. Here's another angle where you can see how the system looks. And here you can see the beginning of the early flow tests where we were trying to determine if we could get the flow through the filter with enough speed that there will be no overflows or underflows. Eventually, we would start putting the seedlings while we were still cycling to try to save some time. And the seedlings had no problem whatsoever in growing. You can see the early lettuce seedlings were placed in rock wool. The rock wool itself was then placed in lava gravel that would sit inside the net pot, which would then rest in the styrofoam. Here you can see the first strawberry plants that were placed and some early tomato plants as well. And here you can see an early view of the system where everything is starting to flow and grow. Initially, we only had one filter, but quickly we realized this would not be enough. So eventually we had to add a second filter and some sort of valve system to be able to control the flow going to both of these filters. Here you can see another shot of the system. The lettuce seedlings are considerably growing now. The strawberries were also growing, but you will be able to notice very clearly the difference in color in the leaves as part of the nutrient deficiencies that we believe we were having. Here's a close-up of a lettuce. You can see some light damage on some of the leaves. This has been so long ago, I don't remember exactly what might have been causing this. But overall, the lettuce plants did quite well through time. Here you can see the first strawberries growing despite the clear deficiency visible in the leaves. Here are some more strawberries growing. And here you can see, once again, the plants still growing despite the nutrient deficiencies. At some point, we started dosing this system with some chelated iron, if I remember correctly, as well as seaweed extract, SM6. More information can be found in the Master Thesis, which I will link to in the description below. Here you can see the first tomatoes that started to appear, some more strawberries. Again, you can clearly see the deficiency in the plants. This discoloration is not normal for a healthy strawberry plant. And here you can see once again how the system is still doing rather well despite the deficiencies. And this is now fully into the Swedish summer with really good temperatures. You can see again the tomato growing. The lettuce still growing quite well. At some point, we also added an air stone in the deep water culture to prevent any root rot that might happen. And here you can see the valve that I talked about earlier. This valve was needed when we added the second filter because we were having issues with the filter either overflowing or the water level inside the filter not submerging the media enough. So we had to regulate to reach an optimum flow where most of the media was most of the time submerged, so we could get most of the effects from the nitrifying bacteria. At some point, we also added some basil plants in the nutrient film technique pipes, and we started observing some slug damage. Unfortunately, we didn't really have many tools to fight the slug damage other than some supervision and keen eye. Here you can see the tomatoes ripening and getting ready for harvest. And now talking a bit more about the results during the operation of the system. Starting with the temperature, you can see the temperature steadily increasing as we approach the summer months. Regarding the pH, we started with high pH during the cycling, and then as the nitrifying bacteria were getting settled, we lowered the pH to more expected levels. Regarding the ammonia and ammonium, you can clearly see the decline, which was totally expected throughout the operation. However, in nitrite and later in the nitrate, you would see a rather odd spike there, which might have been during some sort of issue with the filter, because we did have some issues with the filtration, the biofiltration that is, during many stages. So this might be an outlier point representing that. And then of course we did as I talked about in the other video, we did a more intense 4-day sampling. So 4 days straight sampling. One day we sampled, then we added the nutrient source, in this case fish feed, and then we recorded what happened in different parameters in the system. So looking at the total ammonia nitrogen here, you can see that there wasn't really a significant increase or decrease after the addition of the nutrient source, which indicates that at least part of the nitrifying bacteria were operating well. Regarding the nitrate, there was a bit of an increase, though followed by a decrease straight afterwards, which also means that the bacteria responsible for oxidizing the nitrate were also operating well. And the nitrate was just overall decreasing, which means the plants were uptaking the nitrates in the system. Phosphate didn't really increase that significantly throughout the sampling. The oxygen level did decrease slightly after the addition of the fish feed, which is completely expected as the nitrifying bacteria consume oxygen during their metabolism. So this was about the last picture I took of the system before we decommissioned it. We did harvest quite a few strawberries and tomatoes and lettuce from it. Overall, there were not really big problems with the fish, but I would say that I would completely redo the solid filtration, because even though the biofilter system was working properly, I would really not design this solid separation in this way, because it's really not practical to remove the solids once they get into that type of filters. But with that being said, I hope this video was somewhat interesting to you. Thank you for watching, and I will see you in the next video.